So let's look at a typical Boyle's Law problem. A cylinder equipped with a movable piston has an applied pressure of 4 atmospheres and a volume of 6 liters. Okay, so those are the initial conditions. Our initial pressure is 4 atmospheres, our initial volume is 6 liters. What is the volume if the applied pressure is increased to 1 atmosphere? So the new pressure is decreased to 1 atmosphere. What is our new volume? So we're going to use Boyle's law, which is P1V1 equals P2V2 to solve for this. And since we are decreasing our pressure, our volume is going to increase. To get a smaller pressure, this piston is going to move up. So we're going to use that to help us understand if our answer makes sense or not. So let's plug in our values. Our first pressure is 4 atmospheres, and our first volume is 6 liters. And then that is, where's my pen? Okay, and that is going to be equal to our second pressure, which is 1 atm. Just ignore this, I was trying to find my pen there. And then our volume is which we're solving for. Okay, now we're just going to use algebra to figure this out. I'm solving for an unknown is being multiplied by this value, so I'm going to divide both sides by 1 atmosphere. Let me move my mouse out of the way. So my atmospheres cancel out. And I'm going to come over here and divide this side by 1 atmosphere. So my atmospheres cancel out. So when I do my math, this all cancels out, so I end up with my unknown V2 all by itself. 4 times 6 is 24, and it's just going to be 2 sig figs, since we just have 2 sig figs everywhere, and my units are going to be liters, because all my other units have canceled out. And of course, 4 times 6 divided by 1 is 24. So that's how you solve a problem if you're given your initial pressure, initial volume, and then a second pressure or a second volume. You multiply one side together and divide both sides by your known value, and then you'll get your unknown.